Hello everyone. So today we will discuss about one IoT application system design. Okay. So we will design a system for a connected parking system. Okay. Now let's talk about the problem statement. So problem statement is how to monitor the real-time parking availability status of a parking area in a real-time system. So there are parking area, there are hundreds of parking slot, and out of those 100 how many are full and how many are empty we can monitor in a system which will give me a real-time data. Okay, to do that let's talk about the solution, how we can achieve this. Okay, so this is a high level diagram of our overall system. So in the left hand side, if we consider this is a parking area and we have some sensors which will sense the parking space is occupied or vacant. Based on that, those sensors will send the data in a edge device. Here we have used ESP8266 node MCU, and that node MCU will connect it through a internet via a Wi-Fi, and from that internet the data will be directly pushed into the some application which is hosted in some cloud. So here we have used that AWS Cloud. We are using AWS EC2 to host our all application, backend application and front-end application. So front-end application is kind of a web portal or mobile app. We can directly access that backend application or web application from this cloud service. Okay, so here you can see that in one diagram. This is a high level diagram that will be displayed in a mobile or a website. So you can see the wired connection and wireless connection. Dotted are the wireless connection, and the farm line, the black line, is the wired connection. So sensors, we are using ultrasonic sensors here. All the ultrasonic sensors are connected through wire to the node MCU or ESP8266. And the ESP8266 is wirelessly connected with a Wi-Fi and through that with the internet. Okay, and we will design some API to communicate with this edge device with the service. Okay, so let's look at that. So here is very basic system diagram of the solution. So this is our edge. In the left hand side, this is our edge device, that is ESP8266 or node MCU. So this node MCU will call some API which is hosted in this Amazon EC2. Those API are built in the Springboot, and the database we are using the Postgres, and for UI we will use the Angular application. All this application will be hosted in this server. Okay, so some API will be exposed and those API will be configured in this particular edge device. Okay, so we will talk about how we can configure, and that using that API we will push the data from edge device to cloud. And after that, the UI application will be also hosted in the same cloud, and from that UI application user can open it from any website, mobile browser or internet web browser. Okay, so this is our high level diagram. Now moving to the few key points of a IoT application or any smart solution design. Okay, so this is the 4 main steps we have to follow. That is data ingestion. Number 1, data ingestion. Number 2, data pre-processing. Number 3, data processing, and number 4 is data visualization. Okay, so in this case our data ingestion is happening through this edge device. Okay, you can see in this edge device we are calling one API, and using this edge device we are capturing the sensor data and we are ingesting. This is our first step. Now data pre-processing. Data pre-processing means we are getting some sensor data, and those sensor had some different tags and different values. Okay, and those information need to be some processed, like I am getting a tag which is like very technical in the name. but I need to translate that tag name to some human understandable name or user friendly name. I am getting some value, okay? So maybe that value is some in other unit. We need to change it to some other unit, or I am getting some boolean. I need to display it something in other format. So those are the data pre-processing. And also we are getting, suppose 4 or 10 sensor data, and out of those 10 sensor data we want to calculate some other value, those basically called soft sensor, okay, actually which is not a physical sensor, those are called soft sensor. Those value also we can process, so those can be considered as part of processing, okay. And suppose sometime we want to calculate some data of a particular time frame, that also can be considered as sometime pre-processing, okay. And now after that pre-processing we will talk about the data processing. Data processing means our basic business logic, okay, or the solution logic, okay. So if I get a value of a sensor that measurement distance, okay, if I see one parking lot, one car is present, then I will see, okay, that particular I can sense if my distance is 1 meter, that means, okay, I can think, okay, there is a car. If I see now if in front of the sensor the distance is 5 meter or 6 meter, then I consider, okay, the area is vacant, that means the parking place is vacant, okay. So suppose here is my sensor, okay, so this sensor will measure the distance. Suppose the distance between is 5 feet, okay. The sensor will, if it says my in front of me now distance is 5 feet, that means the parking lot is empty. If it see, okay, there is a car, the distance will be less, so it will be suppose 1 feet, okay. So if I see in the data processing section, if I see, okay, the sensor value is 5 feet, that means I will consider that as a vacant. If I see the distance is 1 feet or less than 5 feet, that means I will consider that as a parking place is occupied, okay. So those are the business logic and the data processing. So if I see the business processing logic will be, if it is more than 5, then it will be considered as a, I will mark our system as a vacant. If I see it is less than 5 and more than 1, then I mark that parking area as vacant, occupied, okay. So those are the things we need to consider, okay, as part of business data processing, okay. Now I will process the data. After data processing I have to visualize the data. That means I need some user interface to visualize the data, okay. So in this diagram you can see there is a part that there is some visualization you can see here, that is showing which are the parking area is occupied and which are the vacant, and it is also giving some the statistics. Now this parking area availability, this is 3 parking available out of 6, and is also saying, okay, the slot 1 is vacant, 2 is vacant, 3 is vacant, 4, 5 and 6 is occupied. So this visualization also we need to implement as part of data visualization. So this can be developed in Angular application, and for the solution we will build in the Angular application, okay. Okay, now let's talk about the data ingestion part, okay. So data ingestion part is how we can ingest the data. So initial first step, we have to build some API in Springboot, and that to be hosted in cloud, okay, or any cloud server. So my API is exposed. Now I can consume, I can write simple program in C++, okay. I can use any editor, okay, to run that, to program this edge device, okay. I can write a program in C++ for suppose any HTTP client, and that HTTP client will call the API, okay, and it will post the data into the API, and from the API we'll take the data and store in the database or update in the database, okay. So that is part of the edge programming, edge device programming. You can use Raspberry Pi, you can use Node MCU, ESP32, anything, okay. Anything. If you use Raspberry Pi, it will be like you can program in Java, C++, Python. If you were using ESP32 or Node MCU, you can use C++. So C++, there are some libraries which is using the HTTP client libraries, and that using that client library we can call the API and push our sensor data. Okay, so we push the data like in every minute. Every minute we will send the data, means it will every minute it will update the status of the all the parking places. Okay, so this was a part of data ingestion. Okay, now we will talk about the data pre-processing. As I said, the clean or filter the data in cloud server. So data pre-processing will be also happen in the backend side, means the in this particular Springboot application we will do this, write this logic to get some clean data and pre-process the data, and we will make the data which is in a required format and shape. Okay, so that will be also done in the backend system that is hosted in cloud. Okay, that is called data pre-processing. Now we'll talk about the data processing. The data processing is nothing but implement the business logic. Okay, so for this case we will implement the data pre-processing or data processing in the backend system, that is a Springboot Java application, so which is also running in this machine, in this server. After this data processing, we will store the data or we will update the data in the database, and after that we will visualize the data. So let's talk about the data visualization. Data visualization or implementation of user interface. Data processing using Angular, data processing, so it should be data visualization. Data visualization should be done with Angular or any mobile app, means Android or iOS. So this Angular dev also should be running in this cloud server. Okay, so we will expose the URL, we will open the URL for whole world and or any specific particular business domain or IP. So from there they can access that particular service or the Angular application. Okay, if you build an Android application, that runs in a standalone format. Okay, so this is how we can develop one end-to-end application, that is Angular, using Angular, Spring Boot, Postgres, using C++, and infrastructure wise some Node MCU, and the software infrastructure wise AWS Cloud. So having said that, thank you for this small walkthrough of system design of IoT application. Okay, thank you everyone.